Howdy everyone, and welcome to CSEE 313. My name is Mary, and I'll be one of your TAs. I'm looking forward to a great summer. Okay, so let's get started. Our labs have two different types, and you can look at the agenda in the master schedule for specifics on due dates and when things are assigned. So first up, we have learning exercises, and these are designed to be a simple introduction to lab content as well as review of lecture content. So, um, yeah, they're coding examples. They should get you a good foundation for upcoming programming assignments. Our programming assignments are more in depth, and we will have a video for each PA going over the expectations, going over the starter code, and going over documentation. So we have a total of about 8 learning exercises. This number might change throughout the semester, but for right now, we are planning on 8. Each LE is roughly 1 week duration. Yep. We will have 4 total programming assignments with varying complexities each. You can read through the details here, but that's the idea. Some are definitely more time intensive than others, and each PA is given roughly 2 weeks. Again, look at the master schedule for more details for all of these. So, code submission. We will be using GitHub Classroom to submit and manage code. Each assignment has a document that has a link where you can accept the assignment. Once you accept the assignment on GitHub, it will generate a repo. And then once you have that repo, you can clone it just like any other Git repo and commit to it, push, all of that good stuff. This is helpful just for background, since this is fairly industry standard. This should give you good experience using Git. The full classroom setup is going to be covered in LE0. That's the whole idea behind that exercise. So PAs are going to be auto-graded. So once you've committed and pushed to the repo, an action gets kicked off and will run the auto-grader test cases. 70% of the test cases are going to be public that you will see the results from immediately. The remaining 30 are private. These private test cases cover stuff like edge cases, stuff like stress conditions. If you read the PA document carefully, you should be able to receive full credit for your PA. The document goes through everything. Also, feel free to add your own test cases. The autograder is you can append to it. So if you think of edge cases, stuff like that, definitely feel free to add your own. LEs are also autograded. 100% of the test cases for LEs are public. So once you see the score on the action, that should be the score you get for the assignment. So our code environment, we will be using Linux to run our C++ code. We also will be running on virtual machines. We do this so that you have an isolated environment. So code that you create, which often uses system calls that could brick your environment if they're not used totally correctly. We want to run those isolated from your machine, so you're bricking a VM and not your device. So we show these 4 options. There are more, but these are the 4 that we recommend. You can use WSL2 for your Windows machine. This is a more lightweight environment and looks like an application that's running on your desktop. A lot of people prefer to use WSL2 if you have a Windows. You can also use VBox for your Windows or for your Mac. This is what I will use primarily. It's just because it's an obviously isolated environment. I like coding in this. You can also run several different environments on your VBox, and that's a nice feature. You can use VMware Fusion if you have an M1 Mac, or if you don't, if you're between machines, if you like using the cloud, if you, for whatever reason, want to use AWS, you can use the Cloud9 option. Cloud9 is the Amazon AWS IDE with Ubuntu. So if you use AWS, you'll need to learn GitHub, Git CLI to run this. We recommend VS Code as the IDE. However, if you're able to edit C++, you can use that IDE. So I've seen people use Notepad++. I've seen people use Sublime, brackets, etc. Use your favorite IDE as long as you're able to compile C++. Okay, so software. Here are the links of the 4 different options. These links will be videos that walk you through setting up your environment. Once you have your environment created, you should install these packages to be able to compile and run the C++ code. If you're using VS Code, we recommend installing GitHub Classroom and the C++ extension pack. GitHub Classroom makes it easier to accept, clone, push your assignments, and C++ makes IntelliSense. It looks nicer. Yep. So some help resources. We have GDB documentation as well as some address sanitizer and Valgrind documentation available on Canvas. Look through that to get yourself a little bit more help through documentation. Once you've done that and you still have questions, feel free to send a question in Microsoft Teams. So you can post to a channel. We will have channels for every PA. You can also post a DM to one of our teaching staff, and we try to be pretty responsive in responding to your team's messages. You can also go to office hours. So we will be having office hours over Zoom. Look on Canvas and Teams for more details. Also feel free to email or DM us with suggested times to set up a one-on-one appointment. And that's good. So email is our last resort. You can use, if for whatever reason one of the other options isn't working, or we ask you to email us. Yep. So this is my 3rd semester teaching this class, and after a year, here are the common things I'm seeing people struggle on. So I compiled them here. So first thing, commit early and often. It is a lot less painful to recover from a day or a couple hours of work than it is to recover from losing all of your work on a PA. You also tend to crash on the day that a PA is due. So committing early, committing often helps you not lose all of your work when you have a computer crash. You also use reasonable commit messages. So this helps when you are trying to debug an issue that was committed in the past, and you're trying to figure out where that issue was introduced. If you have reasonable commit messages, it helps figure out what went wrong. Practice dry coding, so abstract code blocks away into functions. You've heard this before. It makes it easier to manage your code, makes your code more readable. Also make classes. Again, it helps readability and makes it easier to maintain. Last and but very important, learn how to use a debugger and read a trace. So we have GDB documentation. That's the debugger that we are going to be using. Learn how to set a breakpoint, print variables, step and continue, in your execution and run backtrace. So this is all very useful for when you are debugging. Also, when you run into a seg fault, an overflow, a leak, anything of that nature, these all look very similar. So the first thing that you should do is enter GDB or LLDB if you're running on a Mac, and pull a trace. So this, once you have a trace, you will get exactly what the issue is, as well as the line that issue happened from. And a lot of times, if you ask a question that's, I have a seg fault, what do I do? The first thing that I will ask you to do is give me that trace. So that will help me if you have already looked into your fault that way. So you can ask questions right here since this is a video, but please ask questions in Teams. Please email, reach out to us if you have questions on the setup. Thank you very much.